All right. Hello, everyone. Welcome to the Python and Consulting Workshop. Today, Naveen and I will be going over Python, into Python programming, its applications in the industry of data science, as well as consulting, as possible toolkits that Python programmers use for data science. And I'm Pranav, and I'm a sophomore studying computer engineering. And I'll be presenting with Naveen, who is a junior studying electrical engineering, and we're all PMs for the Kraft Heinz and Aramark teams, respectively. So here's a brief agenda of what we'll be going over. So first, Naveen will be going over an introduction to basic Python programming. We'll pretty much uncover basic data structures, iteration, conditionals, things like that. And then I'll just be summarizing how Python can be used in data science as well as consulting, and why data science is extremely important in the consulting sphere, especially today and in the future. And then both Naveen and I will be going over various Python libraries, which pretty much just serve as toolkits for Python programmers to accomplish various tasks when analyzing data, as well as coming up with predictive models and machine learning models. And follow that up with a brief or a Q&A.
All right, with that, I will go ahead and get started. So what's on the agenda for how exactly we're going to learn Python? So for starters, we're going to go over the basics of programming. This is in case you've not taken any sort of introductory programming class, and just to bring you up a little bit to speed. And then after that, we'll talk a little bit about conditionals. I'll come to what that is in a second, but essentially it's like if you want to do something only in a certain case, repetition is just, instead of, let's say you want to print something 10,000 times, instead of typing it out 10,000 times, how exactly can you sort of automate that process? Data structures is essentially, what are the different ways you can store data, and why exactly each type of data structure is useful. Like, for example, an array is the most basic data structure, whereas you could use something more complicated like a queue or a tree or something like that. And then towards the end, we'll go a little bit into how you can understand the errors that you run into, because as a programmer, you are guaranteed to run into errors in any sort of form. And so it's important to understand why you're running into those errors, and more importantly, how to figure out how to get rid of them and debug those errors. All right, so I'm trying to figure out how exactly, yeah, cool. All right, so can everyone see my Colab screen right now?
Yep.
Okay, cool. So essentially, usually initially what I was thinking of doing was I was just thinking of sharing my screen and writing code and then running it on my local computer. But then I realized that that wouldn't be super useful, because you'll have to install a bunch of packages and stuff like that. Whereas for this, all you need to do, I'm actually going to drop the link to this in the chat in case anyone else wants to follow along. If any of you guys are on your computer and you want to run the code with me, go ahead and do so. Essentially what this is called Google Colab. It's basically, think of it as like an online computer that you can just use to run code. So it's sort of like an online compiler. Essentially what you can do is you can just type Python code in this, and then you just click this nice play button and it runs the code for you, and you don't need to install anything on your computer. You just go to colab.research.google.com and then you're good to go. And all you need is a Gmail account. So it's really useful. All right, so let's start off with the basics of the basics, which is essentially printing. So let's say that let's say I want to write code that will essentially tell me hello world. Like as soon as I click run, it'll print out hello world and it'll show me that. And essentially the command for that is print in Python. In C, it's different. In Java, it's different. Every language, the thing with programming languages is the logic is the same. However, the way you write things out is different. It's sort of like, imagine it like a story. Like the story is the same, but the words that you use. So it's different from English to French to German, etc. And so that's what programming languages are like. And over here, I'm just explaining the logic behind things and a little bit of syntax, but the syntax is things that you can Google. It's the logic of things that need to be learned, and then you can't really unlearn them because it's intuitive. All right, so right now I'm printing hello world. That's the first thing I'm going to be doing. And then I'm creating a variable X and I'm setting it to a value 1, and then I'm printing that. And then over here, I'm basically taking a string is basically like a phrase, and I'm setting it to hello BCG, and then I'm printing out the value of that. And then this is just the way that you want to, if you want to print out a string as part of another string, this is how you do it. And so now I'm going to click run. The first time takes a while. There we go, perfect. It printed out hello world, it printed out the number 1, which is what I wanted to print out, and it also printed out the value of y is hello BCG. All right, so now we know how to print something. So now what do we want to do next? The next thing that we need to do is arithmetic, simply because a lot of stuff that you want to use a computer for is because you want to do math that you don't want to do on paper, right? That you want to be able to do faster. So the first things you need to understand are basic operations. So, addition, subtraction, multiplication, and division. And lucky for us, Python is not very complicated. It's literally just the exact same operations as usual. So if you want to create a variable called z and make it equal to x plus y, you literally type x space plus space y, and then automatically it's assigned. And right now I'm printing it out. And so I'm just going to run this. So as you can see over here, even though x and y are both integers, when I printed out the value of z, it gave me a value of 0.5. This is why a lot of people use Python, because you don't have to worry about like casting it. So casting is essentially changing from one type to another. And so what Python does is it can automatically sort of intelligently understand what type it is that you want, and it'll sort of give you a suggestion type. In this case, it's called a float. A float's basically a decimal point number. All right, and at any point, if anyone has any questions, feel free to drop them in the chat, or feel free to unmute yourselves. After I finish every section of this, I'll take a 30-second pause or a 10-second pause, just so in case anyone has any questions, they can just ask right away. All right, so any questions so far? Cool. All right, so now let's move on to conditional. So what is a conditional? So let's say that I want to find out whether or not the value of x is positive. And right now I'm initializing x to 0. So initializing is basically what you set the value to at first. And so essentially, if x is positive, this is the condition that you use. So basically what I'm saying is, if x is positive, I literally wanted to print out x is positive. And so this is where you'd use something like a conditional. A conditional is essentially, it will go into this statement, like the statement that I'm highlighting, only if the statement above it is true. So if x is larger than 0, it'll go into here. Elif is short for else if, and then it'll say else if x is equal to 0. This is basically how you compare values in any programming language. You set equals equal. So let's say I want to check whether or not x is equal to 5. In that case, if x is 5 or not, I just change that to a 5. And so it'll print out x is 0. And then else, if it's neither of those two, obviously it has to be a negative value. So that means x is negative. And so now let me run this. And there we go, it printed out x is 0. And now let's try to change the value just to see if it works or not. And there we go, now that I put 10, it prints out x is positive. And let's double check with negative 10. And there we go, x is negative. So this is how you do conditionals. And a little bit more complicated version, this is something called Boolean algebra. If you're unfamiliar with it, that's fine. It's essentially, it's basically saying if you have two statements and you sort of combine them, you can combine them in two main ways. The first is using an or, and the second is using an and. An or statement is essentially, let's say I take the statement, my name is Naveen, or my name is Pranav. And since one of those things is true, the output of that entire statement is true. And so, however, if I were to say my name is Naveen and my name is Pranav, that's not possible because my name is not Pranav. So that means that makes the entire thing false. And so this is basically a simple way to check whether or not two numbers of the same sign. I'm checking if they're both positive, or if they're both negative, then I print out that the same sign, or else I print out one of them is 0, or else I print out they have opposite signs. And right now I'm setting it to 1 and 3, both the same sign. Let's change it, both opposite sign, and now let's change one of them to 0. And there we go, one of them is 0. Okay, any questions so far? I know I'm going a little fast. It's just because a lot of the stuff is sort of builds up on one another. And so the faster we build those things up, the easier it'll be for us to understand what Pranav is going to be talking about, which is essentially sort of the applications of Python, which is where the more nitty-gritty stuff comes. All right, so now coming to repetition. So now it's called a while loop. Essentially, what it'll say, it's essentially like, let's say I want to print out my name is Naveen like 100 times or something. So what I do is I'd say my name, actually, I don't want to print out 100 times. So let me print out 10 times, okay. And so essentially all I do is that, and voila, it's printed out my name 10 times. I didn't have to actually manually type out print my name is Naveen, print my name is Naveen again and again. And so basically you do that using a while loop, you initialize, then you set a condition, and what happens is it'll keep running these two statements until the statement is false. So every time it's true, it'll just keep going in. And so when you start, it'll be 0, then it'll be 1, because you keep adding. This is basically another way of saying x is equal to x plus 1. They both mean the same thing. So essentially I'm incrementing x by 1 every time, and then once I reach 10, it's no longer true, so it stops. And so this is the exact same thing, except it's done using a for loop. And if I run this, it just prints out all the values from 0 to 9. All right, and I'm just gonna quickly go over what exactly a data structure is. Is this the one? Yep, this is the one. Okay, so essentially there are multiple ways for you to store data in a particular program. So the easiest way is basically you take some memory and you're like, okay, I want all these values to be next to each other. And that's what we call an array. An array is the simplest one because everything is linear. So if you want to modify the second value, you just take the first value and shift it by 1, and then boom, you're at the second value now and you can modify it. There are much more complicated ones, especially in Python. So one of the most used ones is what's called a tuple. And essentially what a tuple is, it's a value. It's like, imagine a coordinate. And the thing about tuples when compared to arrays is that you cannot change the value of a tuple. And that's one thing that's a little bit confusing to a lot of people, is that if you say tuple equals tuple plus 1, it won't change. It might return an error or it might not do anything. It depends on what context you're programming in. And so just creating an empty tuple is literally just open close parentheses. And then if you want to create a tuple, you just put commas in between values, or you can just parenthesize them and put commas in between them. It doesn't really matter. And then all of this is simply operations. And again, if you do have time after this, feel free to go look at this. This is a really good Colab tutorial that I found online. It basically goes over the applications of Python and data science with specifics to data structures. And so it basically goes over a stack. A way you can visualize a stack is that it's like, imagine you have a stack of plates. So every time you want to put something on it, you basically add it on top. And every time you want to take something off, you also take it off from the top. So that's why, if you want the last value, you'll have to remove every single thing before it. And so it's very useful. Like for example, okay, could you quickly discuss why you would use a tuple versus a list, like a scenario in which you would do this? Okay, so a typical example of using a tuple is in the case of coordinates. So for example, once you do get a coordinate, you don't want to modify it, which is why you'd want to use a tuple. Whereas in the case of a list would be, let's say, for example, I want to store names. And let's say I accidentally made a typo in one of those names. I could always say, okay, let's say I have a list that just comprises of Naveen and Pranav. And let's say I accidentally misspelled Naveen. What I'd say is I'd take the list, go to the first element, and then change the spelling of Naveen to the correct spelling. And so that's an example. Very good question. That's the fundamental difference between the two, is that one can be modified and the other cannot. And usually if you want to, like, if you're sure, if you want to keep a constant stored in a tuple, whereas if something that might potentially vary according to time, keep stored in a list. All right, and one fun fact about a stack is that, let's say you want to, so every time you press undo, the undo button, all of those commands are stored on a stack. So that's why whenever you take a command, you write it to memory, and then another command. So let's say I Google my name, and then I Google Pranav's name, and then I Google someone else's name. Whereas let's say I want to go back, in that case, I just press undo, and it would take Googling Pranav's name as the most recent action, which is why it's stored on a stack. A queue is basically the opposite. It's like a line of people, where essentially you would, the first person, like the first element you put in will be the first element that you take out as well, on like a stack. And so a dictionary is basically, it's similar to an array. An array is essentially you take the first index of a number, the second index of a number, the third index, and then you just put values in it. So let's say you have a list of names. So Naveen, Pranav, Liz, 3 names. I'm putting all those in a list. So the first element is Naveen. So that means if you take the array and you take the first value, like takes the value corresponding to the index 1, that corresponds to Naveen, 2 Pranav, and 3 Liz. Whereas in the case of a dictionary, you can actually change those indexes that you use. So for example, let's say I want to say, okay, take this dictionary, and if you call the dictionary using the value Naveen, then it'll actually return my last name or something like that. So you can sort of relate values using not only, like, it's not necessarily first, second, third. It's now like you can index it using using whatever value you'd like to. It's also called a hash map in other languages, but it's called a dictionary in Python. Those are the most important data structures. And I'm going to stop for a sec because I know data structures can be pretty complicated. Is everyone following? Does anyone have any questions they'd like to ask? Okay, perfect. with that, let's go on to errors. Oh, I already ran the errors. Okay. So basically what this step does is that we're going to be discussing what exactly are the errors that you can run when you're running Python code. And the reason understanding errors is important is because A, you're going to run into them frequently, and B, a lot of errors are, some of them are very, very general. However, some of them are super specific. And so for that, if you see over here, there's this search Stack Overflow option. And so Stack Overflow, again, I'll mention this towards the end of the presentation, but there are certain resources that you can look up for code. For Stack Overflow is a very good one. Geeks for Geeks is also very good, but that's mostly for algorithms. And GitHub is also a very good place. GitHub is essentially like Google Drive, but for code. And so you can store code on it. Other people can access it. It's a lot of people think of it as like social media for code. But so over here, this is the most basic one, which is a syntax error. This just means that you typed something that Python doesn't allow. Like for example, this while true statement is not really allowed in Python because I don't think, I think you need to have it on like a separate line, I believe. This should work. Yeah, okay, that was, whoa, that crashed, whoops. I should not have run that. All right, cool. All right, yeah, I'm gonna change that back to what it was before because if any of you guys run it, it'll break. Okay, cool. So the second one, Python errors are much better than other error languages, errors in other languages, just because of the fact that Python's much more high level, so it's easier for, it's custom designed for developers. So zero division error, this is just because I divided 1 by 0. BCG equals cool. This is just because I haven't defined what cool means. So it's not going to work unless I initialize what cool is, or if I make this a cool string. 2 plus 2, 1, 2 is a string, the other 2 is an integer, so that's a type error because you can't add things of different types. Open bcg.txt, there's no bcg.txt to be found, so it just says file not found error. Over here, this is one of the index errors I mentioned before. So if I take a list and I add Naveen, Pranav, and Liz, and I'm like, okay, tell me the 10,000 element of the list, it's going to be like, hey, you've only added 3, so I can't return the 10,000th one. And also, the reason it didn't work for 3 either was because the fact that indexing starts at element 0 and not 1, as in the case of MATLAB, in case you're familiar with that from engineering. Import not a module. This is just module not found. A key error is like, as I mentioned before, in hash maps, you have dictionaries, you have keys, and they don't necessarily work all the time because you need to make sure that you're inserting the right key. And if you insert a wrong one, it'll just return a key error. And then this is just typecasting. You can't cast a string to an integer because that doesn't make sense. But with that, that's all I have for the intro to programming one. I know that was really, really quick, but does anyone have any questions they'd like to ask? And if you remember a question later, just feel free to drop them in the chat. I'm going to hand it over to Pranav now, and he's going to go over how exactly we can use these fundamental programming concepts that we've just learned.
All right. So before I go into sort of the direct applications of Python in data science and consulting, let me set the stage and sort of describe how data science is playing such a big role in consulting. And before I start, I would like to say that, especially for the future, based on what consultants from the top 3 Boston Consulting Group, Bain, as well as McKinsey, based on what consultants from those high top consulting firms are saying, data science is going to be very, very important in landing those type of jobs. So in the future, it looks like what it looks like is that data science is going to have at least some knowledge of, if not expertise in, if you want to work in the field of consulting. And so I'll go over the brief reasons for why this is. So the way I look at it is that when you boil consulting down to a very general, simple mission statement, you simply, based on certain information that I get from your company, what strategies and recommendations and conclusions can I make? So this information that we get from the company obviously is very important, right? So usually this information takes the form of data for the reason that it is very precise and very accurate. Usually every metric or any piece of information that you get about something can be boiled down to a number in the form of data. And usually when you take a large amount of this data, that's when you start getting yourself in the field of data science, which pretty much is using the technology and various algorithms to sort of harness the data and analyze it to make conclusions about the past, and using these conclusions make various predictions about the future. and also recommendations and strategies from those quantifiable predictions. And right now, I would say I would say in consulting, a consultant's job would be mainly to work with these automated statistical models to sort of use give the data input so that you can get the conclusions that you need about what you're working on. And a big part of data science would be sort of coming up with predictive models from data input, so that you could sort of given a set of various parameters, sort of come up with a quantifiable output, describe what any future sales or any future predictions would be. And sort of the key when making these predictive models would be to make them as accurate and generalizable as possible. So what I mean by accurate would be simply these whatever outcome that you predict has to be as close to the actual outcome that actually happens, and pretty much apply very minimal error from the actual outcome. So minimal error equals more accurate, right? And then this is sort of the opposite from generalizable, which means that you sort of have to come up with a balance between the two. So what it means when you have a generalizable predictive model means that pretty much means that whatever predictive model that you come up for the future has to be applied to a very broad range of situation and data sets. So your predictive model cannot be only specific to whatever past data set that you inputted, but it also has to be sort of incorporating any external factors that could possibly be unpredictable, as well as any sort of seasonal factors as well that sort of change the way an output can be quantified and calculated. So sort of that sort of deviates from accurate. However, when you sort of come up with predictive models, it's good to test the various degrees of specificity that you use when creating these predictive models, so that your predictions are usually accurate and generalizable. So maybe you can go to the next slide. So before we go into the Python side of data science, I'll be going over two examples of how consultants use data science in the actual real world. So as I said before, predictive modeling is a pretty big aspect of data science. And an application of this would be to sort of predict demand in the future depending on past sales data as well as inventory data. So one example would be sort of a real store or a restaurant using data giving data to a consultant who in turn develops a machine learning / predictive regression model to sort of come up with a regression model that sort of predicts what output would be generated as a result of future parameters. And with this regression model, you could predict the demand. You can create a demand forecast that is sort of dependent on the previous sales data, so that restaurant and retail stores can sort of prepare for the demand that is expected in the future. And another sort of aspect of data science in consulting would be sort of the security of personal data, such as with healthcare insurance information. And one example of this would be sort of using optical character recognition, or OCR, to sort of protect the personal data of any patient using the most secure authentication algorithms as possible. And sort of another aspect of data science consulting would be sort of coming up with the most secure ways to protect data and sort of create as much security as possible. So here's where I'll go over sort of Python and why it's important in data science. So as Naveen said before, Python is sort of like so various languages, it's sort of like using different words for the same outcome. And I'd like to further that sort of analogy by saying that it's like using various languages that have different words and like also have very different structures. So there's various things that would be needed in other languages that are not needed in Python. For example, in C programming, anytime you sort of initialize any data structure or anything that you want to sort of work with, you have to allocate memory for that data structure, right? And this sort of can become tedious with other programming languages because you need to watch out for any memory leaks, as well as you need to ensure that you use the least amount of memory as possible. However, you don't really need to do this with Python because Python sort of does that for you. And this is not the only example of a situation in which Python does something for you. And the way I like to think about it is that the path between whatever you're thinking in your mind and what you actually put in code is very short with Python compared to other languages. So with other languages such as C, C++, and even Java, usually you have to think long and hard about boiling whatever your task is, the very like minute parts, so that you sort of tackle every single specific detail of that problem. With Python, you don't really need to do that because it sort of gives you the sort of high level programming, as Naveen said before, that you to sort of just think of just like pretty much just like put whatever you're thinking on the screen, and sort of and Python is also very close to English language when it comes to actually programming. So it's not as difficult to learn the actual code. However, the reason why Python is very useful is because of things like data science and machine learning, which takes a large amount of implementation and algorithms and things like that, which is what makes Python very unique and very special. So yeah, as I said before, you don't need to derive the very basic components of a problem by yourself. Instead, Python kind of does that for you and allows you to sort of think to a high level and sort of just deploy what they give you in an actual real life problem. And another reason why Python is very useful is because of the various toolkits and libraries that sort of just give you methods that allow you to sort of allow the machine to sort of just accomplish what you want them to accomplish. And this is really useful because, as I said before, you don't need to actually you don't need to actually boil these functions down to their small components. And yeah, so libraries are very useful for that. And these libraries sort of give you the methods needed to do various tasks that would be very complicated in any other language. And one last point would be that Python is very easy to scale for large data sets. And the reason for this is because it's usually a lot faster and like other data science languages such as MATLAB and Java. And it allows you to sort of use train very large data to sort of come up with very comprehensive predictive models and so forth. All right, next slide. So now we'll sort of go over the various libraries that Python comes with, and these libraries are very specific to data science in particular, and make a data scientist's job very easy. And so a library pretty much is just a set of data functions and data structures that reduce the amount of code that you need to sort of accomplish a certain task. And what I mean by this is that anything that you sort of want to make in a programming language like Python, you can sort of be given to by a library, and all it takes is just grabbing a certain method from that library and you're just using it. And each library has their own purpose. And as I said before, data science has a lot of libraries for that purpose. So we'll be going over certain libraries that sort of accomplish certain things with data science and how to use them. You first have to install these packages using any terminal command, or even within your built-in IDE. So a lot of these libraries sort of just, they're in your IDE. It's just a matter of you going in and installing them. So like I know IDEs such as PyCharm, Visual Studio, Anaconda. They all have various menus that allow you to install any packages or libraries that you would like. And when you install these packages, it's important to import each. Whenever you use them in code, you have to import them at the top of your document. And you can also import them in shorter names. So as you can see in the bottom left, we're importing both numpy and matplotlib.pyplot as a certain name. So when we actually refer to these functions in these libraries, we don't need matplotlib.pyplot. We can just refer to them as plt, and the same goes for numpy as np. So this allows us to pretty much just reduce the typing that we need, and it just makes it a lot easier to sort of use these libraries in your actual code. And when you refer to the library, you obviously have to refer to their names. So if you look at the bottom right, like when you want to use a function in matplotlib, you would say plt.show, and this function pretty much just shows the graph that you're working on and displays it. All right, next slide. So these are the various libraries that we'll be working on or describing. So NumPy is very useful for regression models in the fact that it allows you to sort of create these matrices that can be used to determine the coefficient of your regression equations. And then we'll be going over Gurobi, which is something that's important in optimization and linear programs, which deals with maximizing and minimizing objective functions with the constraints. And then matplotlib, which is simply just a visual GUI library that sort of displays whatever graphs you're generating by inputting whatever data that you want to input. And then scikit-learn, also known as sklearn, is sort of also for regression, except it's a lot more intensive and a lot more detailed. And TensorFlow is usually it's also very regression based, but also it's used for a lot of things in machine learning as well. I'll be going over NumPy first. So the reason why NumPy is important is because when you create regression models in Python, or in general, like in math as well, this usually is the creation of matrices and the use of matrix functions such as dot product, inverse, transpose, sum, those sort of functions. And usually when you collect data using a list as Naveen described, you can't really use those functions with these lists and sort of form matrices with these lists, even if they're three-dimensional or two-dimensional. But however, it is possible to sort of use NumPy to translate these lists into actual matrices, which you can sort of work with and use and sort of manipulate using functions, inverse functions, transpose functions, and sort of create matrices with them, and then perform matrix operations between matrices as well. So NumPy, it's really easy to sort of convert a list to a NumPy array. And as you see in that code snippet on the right, that's pretty much a least squares regression model using using the NumPy library. So the first two commands where it says x equals np.array x and the same for y, we're pretty much converting x, which is a list of features, which is pretty much in not the coefficients, the input data set. It's pretty much a list of all of that, and it sort of converts it into an actual matrix and redefines x as that matrix. And the same goes for y, which is simply just the output matrix that we have collected in the past. And then in the next two lines, we sort of manipulate these matrices using functions that are very specific to matrix algebra and NumPy itself. And such functions include transpose function, dot function, as well as inverse as well. I won't go over the actual math with these actual functions, but these are usually algorithms you find online and that are sort of that you can sort of put to practice using NumPy and Python. And then our final result would be our coefficient matrix for regression model, which is sort of just a dot product between the two matrices that we find before. So as you can see with this code, we can sort of implement matrix algebra in Python using NumPy, which is why NumPy is really important for linear regression modeling, as well as polynomial regression as well. You can go to the next slide. So I'll be talking about Gurobi as well. So before we actually go into Gurobi, the problem that we're trying to solve with Gurobi, they're known as linear programs, and a linear program pretty much is contains an objective function as well as a list of constraints. So the objective function usually is an equation or an that sort of inputs of x1, x2, and so on that describe certain things. And we can either maximize or minimize that depending on what the problem is. For example, usually a profit linear program would deal with maximizing your output, which is your profit. So it depends on the actual problem, but you can either minimize or maximize a certain expression that inputs the parameters and metrics that sort of like describe what your output is. And then we follow that up with like a list of constraints that are pretty much determined by what physical as well as any labor constraints that you have when actually putting these inputs to practice, as well as the actual constraint. As you can see in the bottom two constraints, obviously your parameters usually have to be greater than 0 for like you create like producing negative product, right? So usually you have those constraints as well. And I would like to say like a good example of a linear program would be, let's say you have two products, x1, x2, and each product creates this much profit. So you would create an objective function that would maximize the profit per unit for each product times the amount of product created, and you just add that up to add up potential profit you can make from that linear program. Constraint should be sort of along the lines of this: we have 2 or 3 machines, and we can only dedicate this amount of time for each machine, and this much time is dedicated for each product. So how much? So like these constraints would pretty much determine how much time can be created for each product, depending on how much of each product is made. And there could be like a number of machines that sort of come up with a multiple number of constraints. And obviously we can't have a negative amount of products, so we'd have each of those parameters be greater than 0. And we sort of have that linear program, and it's a very important part of be sort of creating that linear program and coming up with the various constraints and objective function. And that sort of brings me to Gurobi itself. So Gurobi pretty much inputs this linear program in a way in which you just pretty much just type out all the constraints, type out the objective function, and it sort of just gives you the optimal point depending on what your objective function is. Like for example, if you see the visual right there, if you graph a linear program, usually the optimal points would be at those various vertices that would or edges that sort of describe whether it's a minimum or maximum, and you sort of input that into the objective to see whether it's what you want and whether it's the greatest value or the minimum value. Gurobi sort of does that for you and just gives you the values of x1, x2, for example, and the n, as well as the value of the objective function, given sort of inputting those variables as well. So that's what Gurobi does, and I know in IE 335, which is a class you take as an IE major, you go over Gurobi and sort of linear programs in general. So this would be a really good thing to practice for that class as well. Next slide. So I'll go over Matplotlib. So Matplotlib is sort of a basic GUI sort of library that sort of generates these plots for you, given a list of data that you sort of generate yourself, given a sort of maybe like an input data set or a predictive model. So these are kind of what our Matplotlib plots would look like if you actually show them in Python. And if you look at the code, I'll just go one line by one line. So initially we're opening up a text file that has data inside. Text file doesn't usually have to be the source of data, but in this case it is. It could sometimes just be a list that you created. And we're also reading all the lines from this text file and organizing it into a list. And in addition, we create these individual lists for the X and Y. And I know Naveen went over iteration. So we're iterating over each of these lines in the text file and X and Y individually to the X and Y value arrays, and then all we really do to plot them is plt.scatter, generate a scatter plot of those two lists, so the x values and the y values, and that pretty much just gives you what you're trying to plot. And it's also possible to just add another PLT statement, plt.scatter method, sort of plot other quadratic or cubic regression models as well. So you can plot numerous multiple lines on one plot, or you can just have a number of more than one plot with a line each. So MATLAB usually makes your life a lot easier, sort of showing what your data is in a visual sense. Go ahead, Naveen.
All right, so now coming to scikit-learn, also commonly called as sklearn. It's essentially just a library that contains a bunch of algorithms. So let's say I wanted to find something that could detect an object for me. Then I would go ahead and just say sklearn dot and then call an object detection algorithm and then run an image through, and then I'll output an image and stuff like that. Object detection is a field that I work with a lot, and we use sklearn to test all of our models whenever we start building something. And it's also very, very good for regression. And the key thing about sklearn when compared to other libraries is the fact that in sklearn, you don't need to write a lot of code. You pretty much just say, okay, I'm going to call this, then I'm going to call that, and then I'm going to call that again. And then I'm going to combine these two and stuff like that. So it's pretty much just a lot of the code you're going to be writing will be 1 or 2 lines. And so that's why a lot of people use sklearn. However, the disadvantage with sklearn is you don't have customizability because everything is inbuilt already. And to write things from scratch in sklearn is pretty confusing. And with that, I'm going to talk a little bit about TensorFlow. In case you're not familiar with what TensorFlow is, essentially Google's machine learning library. It is very, very compatible with Python, and it has recently come up with C++ and Java compatibility as well. And so TensorFlow essentially, in case you're unfamiliar with what machine learning is, as from a really broad perspective, essentially what it is that imagine that you have a input array, like you have an input bunch of numbers, and you want to get an output number, a bunch of output numbers, and essentially you have this black box that it takes the input numbers and gives the output numbers. So in this case, what you can do is you can take an image and you can just convert it to a bunch of numbers, because essentially at the end of the day, an image is just a bunch of pixels, and pixels are just values of red, green, and blue, right? So you just input that array, and then essentially what you do is you're like, okay, if I put this array, I'll get output that, and then you keep feeding in multiple inputs and outputs, and essentially what your black box is, it'll basically know exactly what to do. It'll be like, okay, if you pass in input 1, you get output 1. If you pass in input 2, you'll get output 2. And so the network itself will start to understand whether or not you, like, let's say, for example, you pass an input that it's never seen before. Let's say you pass an input 10.5. Then it'll look at that 10.5 input and it'll be like, okay, it's similar to 10. It's also similar to 11. So let's spit out an output that's similar to 10 and 11. So it'll spit out 10.5. And that's a really high level understanding of what neural networks does. And essentially what TensorFlow, it's a way of writing these networks from scratch. And it's like, okay, I want this network to do this, and I want to feed in these inputs, and then you train the network. Training is essentially what I just mentioned, where you pass in a data set and you're like, okay, for these expected inputs, you're supposed to give these outputs. Like a typical example is if you pass in an object, if you pass in an image of an object and you're like, okay, there's a dog in this picture, and you feed in like 10 billion dog pictures, and if you pass in like 100 pictures, out of which 50 are dogs, chances are it'll be able to get 49 of them, or it might get 51, and it might have counted something that's not a dog as a dog. And so that's essentially a basic example. And the way it's applicable in consulting is that it can help you build very, very accurate prediction models. And one thing that's really cool, which is something that I found online, it is a stock price prediction. And so essentially, I'm not going to run the commands because it takes a really long time to install, and training takes forever. But essentially what you do is you import TensorFlow, you import a bunch of other stuff. And as you can see, this is where the important thing happens. So you input stock data, which is essentially, they have a get Yahoo data function. And you just input the start date and end date, and it'll say, okay, I'm going to take all of the data from 1st December 1980 all the way up until 31st December 2018, and using this data, using that trend, I'm going to see what the trend will look like for the next 2 years. And so that's what these outputs are. It essentially outputs how close it is to the actual value based off of measurement. And I believe it was a relatively good algorithm. But again, that's a very, very high level view of TensorFlow. But with that, that's all we had for this presentation. As just to reiterate, we went over programming concepts, we went over data science and consulting, we went over Python's application in data science and consulting, and lastly,